Hello everyone and welcome to today's webinar. My name is Sharon Madar and most of you know me already. I'm an account executive here at Stratoscale and I'm super excited to be hosting this session today. Today is our 5th session and we'll focus on infrastructure as a code in enterprise environments, and we hope that you're going to find it very helpful. I'm very pleased to introduce today's speaker, Liaz Kamper. Liaz has been with Stratoscale for over 5 years and is a member of our Cloud Architects team. He knows Symphony inside out. Now, before I hand the mic over to Liaz, a few items to cover about this presentation. The webinar will take around 20 minutes. It will be available on demand after the live session, and we will be sending out a recording by email. If you have any questions for our speaker, feel free to send it through the Ask a Question tab, and we will answer your question at the end of the session. If we don't get your question answered during today's webinar, we will be sure to follow up afterwards. So, without any further ado, I'd like to kick things off by welcoming Liaz. Liaz, over to you.
Thank you very much, Sharon. Today we're going to talk about a very exciting solution that we developed in the recent month, and it comes to answer a very urgent need by many of our customers, and it involves heavily Terraform, which is infrastructure as code, and Kubernetes in an on-prem solution. That's my email, so we're going to present it also in the end of the webinar. Feel free to have any feedbacks on this webinar, further questions that you didn't manage to ask during the webinar, and if you're using a solution, which kind of other solution you would like to see. Today we're going to talk about a Kubernetes holistic solution. What's a Kubernetes holistic solution? What is it good for, and why the best way to do it is using infrastructure as code, and why that's the best way to do it. We're going to demo actually a 3-tier application, WordPress deployment, and we're going to fully automate that using Terraform. What is a 3-tier application? We've discussed that several times in the past, because this is really the infrastructure or the basic template for many of the applications you guys are building out there. So let's cover that quickly. In the public tier, okay, in the front end, we have a load balancer, which is exposed outside through a public IP and an internet gateway. The load balancer backend fans out to a target group, and the target group actually consists of all the web servers that you're going to be that you will use for this 3-tier application. That's the front end. You might also have a public instance that will be a jump server in case you want to SSH into one of those instances and you don't want to expose SSH outside. This also has a public IP. Everything, by the way, is in a VPC. VPC is isolated networking domain, which is exposed outside only when you're exposing or creating an internet gateway, and everything lies in AWS terms, but everything actually lies in a Symphony cluster. And next, we have the backend. That's the business logic. This is where the business logic of the application is running, and everything is stateless. So where do we keep the state? The state is another subnet, and that subnet hosts, in this case, a MySQL server. It can be Postgres, and it can be any RDS that we support here in Symphony. So in many of the cases, the centerpiece for this compute is not virtual machines. It gets more and more into the point where it's Kubernetes cluster. What is a Kubernetes? I will not go in depth into what is actually a Kubernetes. Kubernetes is an enterprise container platform. It allows you to run containers in scale, expose them efficiently in a secure way, monitor them, upgrade them, remove them, everything which actually involves controlling containers in scale. But Kubernetes itself is not enough. It needs to come with a fleet of services. So let's go through all the services that Kubernetes usually needs to in order to run a Twitter application. So first and foremost, it needs a VPC, okay, network services. It lies in a network. It needs to be exposed outside. It needs to have a public IP or internal IP in order to control the Kubernetes itself. So everything has to be in a very valid and a very robust VPC networking service. Next, Kubernetes usually, most of the time, runs stateless services. Stateless means that it is non-persistent. So we need to have some kind of persistency. Persistency comes in usually with databases. Can be many different databases. In this case, I chose MySQL. It can be Postgres. It can be some kind of clusters such as Cassandra, Redis, Mongo, anything that you can fully automate and connect and consume using Kubernetes. Persistent volumes, unlike database, you can actually connect persistent volumes to the Kubernetes pods. So it can be EFS, which is persistent volumes that are based on NFS. It can also be block storage. By the way, EFS we already have in the product, and I'll show you it now. Block storage we're going to have in the upcoming version. And you can have persistent object in S3, and the images, you're used to have the images actually lying around in your own cluster. So we need to have that the container registry lies inside the cluster, and the Kubernetes needs to know about that private registry. It will not allow you to connect to any private registry that it does not know, and also need to be secured. The nodes themselves aggregate into a single endpoint, so you need to have a load balancer in order to do that, and you might want to publish the services as is. So let's go ahead and do that. I have here a 5.3, by the way, version, which is our latest and greatest, and we're going to run Terraform apply and see what we get. So what we have here is a fully automated Kubernetes solution. As you can see, I'm going to scan the objects a little bit. So we're going to have a load balancer. Here we're going to have, this case it's going to be application load balancer with the target group. We're going to create databases. That's a full MySQL database and not containerized. It's a real MySQL service with replication and all the capabilities that Symphony gives you. Route tables, EFS, because I'm going to do persistency over NFS, elastic IPs, and then we're going to create, of course, everything is secured in a security group. We're going to create a Kubernetes deployment, and that Kubernetes deployment has a very valid configuration in, usually it's YAML, but in this case, it's Terraform code. I can show you that later. So everything here is Kubernetes, and then we'll create a Kubernetes cluster inside Symphony. Just go yes, and things get created. What's the magic behind all this? So let's look a little bit about in the code. Make it a little bit larger. Fine. So we have here in the code the usual Terraform code that we saw in previously. We have that actually points to Symphony. We have the variables code that defines the API of this service, and this is the only thing that you need actually to define in order to run this application or any other application that you would like to write in such a way, which is a fully automated Kubernetes solution over Symphony. So we have here the AWS part of Symphony. These are these credentials. You need to, in order to run the Kubernetes now, you need to run the Symphony credentials. You determine which kind of Kubernetes cluster you would like to run. I can actually also decide on the number of nodes that I can run. I can scale it while it's actually running. We can see that later. And this is where the Kubernetes config path will be. Some information about the WordPress image I'm going to deploy. In this case, I'm actually deploying the public WordPress. Can also do it from a private registry. That's my exposed port. This is in case you would like to have an elastic EAP, and these are the database, okay, that we're exposing. These are the parameters, and everything else is a regular Terraform. Okay, so we've already seen that in the past. This is how you create in Terraform a database, and this is, for example, how you create the VPC, all the networking that's required. So the new thing that you see here is that we have in 5.3 fully supported EFS creation in Terraform. Okay, and we're going to use this as persistent volumes in Kubernetes, and we have this thing. So this Terraform actually calls a module that we've written, and you can see this module here. That's a Terraform module, and that module will create a Symphony cluster. Since we're creating the Symphony cluster, you can actually go ahead and use that cluster as input to, or as an infrastructure to all the other applications. For example, here I'm creating a WordPress. So I'm wrapping another WordPress application. I'll show you in a minute why am I wrapping this. So these are all the parameters I need for my Kubernetes cluster. So I have exactly where my Kubernetes lies. I have an elastic IP of the cluster, and this is the IP I'm going to use for persistent volumes. You can see that this is actually the IP of the EFS I'm creating. I have all the database I'm going to integrate. So that's actually one of the best part of this solution, that you can have any database. You create a database. If you change it, the deployment will change automatically. And I'll show you in a minute how to do it. And here we have the target group. Once the WordPress will be created, the export service automatically connects everything into a listener and a target group. Fine. So let's see that. Okay, this thing is still in action. So as you can see here, load balancer, Terraform is very strong in doing things concurrently. So load balancer, Kubernetes, and databases as infrastructures are non-related. So things are being created as we speak. Let me just go to the load balancer. You can see that, oh, I did not enable load balancer here. So let me just quickly go and enable that. But anyway, the load balancer have been created, file systems. Okay, so just a second. Okay, sorry. Let me just connect to another system. Okay, so as you can see here, I have the load balancer. Okay, so that's the correct project. I'm working on demo 1. So you can see here the load balancer being created, Kubernetes cluster being created. Right now, we are in the phase of actually creating the master node. You can go to the load balancer. The load balancer is already created. And listeners are missing because we'll create the listener and target groups only when the Kubernetes application is up and running. So maybe that's a good point to show you how do we actually create the Kubernetes application. So what we have here is multi-layer, multi-provider solution. For this specific module, we're not using any more the AWS. Now we need to use the Kubernetes API. So I'm declaring here provider Kubernetes. Provider Kubernetes means this is the API for the Kubernetes. So use that. Where's the data for the API? That's in the config path. The config path is the one that we're creating for the Kubernetes. And here I'm creating, for example, a secret So maybe you know how to create a secret using the YAML, but here I can create a secret using Terraform code. It's very easy. Since I'm using IDE, it's practically code itself. I'm getting username and password, and I'm creating that into a secret. And for example, in the deployment, I'm just saying the WordPress environment variable gets from the secret that I've created, as you can see above. And this is the key inside the secret. Everything is fully integrated. You can destroy this, create it in another environment, a new database will be created, and the new database will be fully integrated in that Kubernetes code. Everything is coded here. So for example, I have here a persistent volume, and it gets an EFS IP, and the claim just refers to that persistent volume. So everything is fully integrated. Maybe that's a time to understand why are we doing all this. So we're doing all this because eventually everything needs to be automated in order to integrate into an automated DevOps machine. DevOps is all about automation, and automation starts with code. So the code usually lies here in a GitHub, a GitLab, a Bitbucket. The Terraform lies here, or your application lies here, and then once you change it, it triggers. It triggers some kind of CI/CD pipeline. So I gave here all kinds of examples for CI/CD pipelines. These are the AWS pipelines. Jenkins is usually the pipeline that you will find in on-prem, Azure DevOps, Azure pipeline, and the Google Cloud pipeline. The pipelines create infrastructure. They need to do it, in most cases, using infrastructure as code. So Ansible, Terraform, Puppet, Chef, we're doing Terraform. And this will create a Kubernetes cluster. So in order to create a Twitter application and automate that into a CI/CD pipeline, you need to have everything fully automated. So far, until 5.2.2, and until this solution came out, you could do all of the creation without the centerpiece, without the Kubernetes. And this actually made this solution unuseful. But now it's very useful because you have also the Kubernetes fully automated in Terraform. And since Terraform now knows the Kubernetes object, the sky's the limit. You can create many Kubernetes clusters connected to each other. You can have many applications running inside the Kubernetes. You have database. Basically, everything you can do in Terraform, you can now fully automate in Symphony. Now let's see where we are in creating the Kubernetes. With this version, it takes, and this performance of machine, it takes about 10 minutes. As you can see, now I'm in the phase of creating the two nodes. The master is created, and now I'm creating a second worker. And I'm deploying a single pod WordPress, but it's very easy to scale, as we'll see later. We'll have the load balancer already running. Let's check out what's going on with the MySQL. So the MySQL is running, as you probably remember. It's a full MySQL. You can replicate that. You can attach parameters. You can also do it using Terraform, resize it while it's running, resize it using API, and so on. So now I need to run Terraform apply again, because in this specific version of Terraform, there's a bug when you're running two providers that are dependent on each other. It scans, it sees that all the infrastructure runs, and now it will create the Kubernetes deployment. Okay, so the WordPress is running, and the only thing I'm getting is an endpoint. And I'm just gonna go ahead, copy paste this endpoint. Right now it will not serve because it will take time for the WordPress to come up, but you can check that by doing this. The kubectl is already in place. So I'm just running kubectl proxy. It will start a proxy service. I'll go to my Kubernetes, ktest, access. I can skip this because everything is already secured, and you can see that my WordPress is already deploying. So you can see that I have here full Kubernetes UI, very easy to access and control, even when I'm creating to Terraform. Then I can actually go to maybe check out my pods, and I can see the logs. So right now the container is creating, and I can go and exit. You can even use the UI to execute code inside my. You can see all the WordPress that were fully integrated inside, or everything I just declared in the Terraform, and you can see it inside the pod. So this is it basically. We can, while you're asking the questions, we can check, wait for the WordPress to come up. To sum it all up, we have, I've shown you a fully Kubernetes automation in Symphony using all this fleet of services and all other services that are coming up in Symphony, such as SQS, SNS, auto scaling group. You can fully automate that into Terraform, and basically the sky's the limit right now in the on-prem. It's a very unique solution, and I'm sure you're going to make a very good use of it. So let's get some questions from the audience. I see that we already have a few questions. Okay, so first question: where should I place the state file? The state file is the Achilles heel of indeed Terraform. If you're using the state file, it's going to be hard for you to get to the state where your new code points to. You can have several options. You can do it in Git, you can put it in SQL, you could put it in S3, or you can use Terraform Enterprise. Whatever you do, make sure it's coherent to your current state. Make sure nobody touched the state file unless it's under review, and make sure you don't use it or corrupt it. What are the main limitations of Terraform? I have another question. So the main limitation is obviously the state. So make sure you always have the state. And in this specific case, that solution can only run, since we're using shell, it can only run on Linux compatible machines, Mac and so on. So we might come up with a Windows compatible machine in the solution in the future. So which AWS plugin should I use? You can use the latest. I think the latest is, can see what am I using. Okay, so WordPress still come up, probably it's initializing its database. So I'm using Terraform version. Okay, so I'm using, yeah, so 2.3, actually, they came into V2.3. Beautiful version. And we're gonna take, last question while we're waiting for the WordPress to come up. What Symphony resources are not supported? So right now in Terraform, the container registry is not supported, and Route 53 is coming in the next few versions. That's still not supported, but again, it's coming, and I think it's going to be very nicely integrated. Let's see what's going on with the WordPress. So okay, great. So the pods are here. The probes are still not listening, not responding, because the WordPress takes some time to come up. And yeah, okay, so it's gonna, you know what, let's go and see, check out the load balancer, see if the load balancer can hear the ports. Again, everything is fully integrated into the UI, so you can just go to the relevant load balancer and see that the ports are still unhealthy. That means that this port is still hear the WordPress, so the WordPress is still not up. Takes some time to initialize the databases and initialize the persistent volume, which is new. Okay, let's see that. Maybe refresh a little bit. Oh, great. So the deployment is currently up and running. So as soon as the load balancer will sense the port as healthy, it will be healthy. I want to thank you for joining this webinar. I'll be more than happy to hear from you any feedback regarding the solution. We will publish the solution, the code. It's going to be in my exposed Strato AWS examples. So the GitHub will be a little bit different. Let me just maybe bring up the GitHub here, so you'll be able to use that. So just to keep the record straight, this is my solution, and the solution, unfortunately, is still in a branch because that's still work in progress. So you just go to this link, and I'll be more than happy to get your feedback regarding this solution, and the WordPress is up and running. Great. So again, thank you very much, Aaron, for hosting this webinar. I'll be more than happy to hear from you guys and hear that you're actually using the solutions and which other solution you would like to get from me. Thank you very much.
Thank you very much, Liaz. We'll be sending out the recording shortly.